We are going to solve generalized Fibonacci numbers. In this question, you are given three integers a, b, and c, and a range n along with the value m. Okay, so you will have to find the Fibonacci sequence, Fibonacci number, and a Fibonacci number. But how? For any given number n, okay, for any given number n, there will be two values a, b, and c, three values. Okay, so you'll have to find a into gn minus 1, b into gn minus 2, then add c. And at the end, when you will get the g of n, the number, the nth Fibonacci number, you'll again mod it with the m. M is also given in the input. And at the end, you will return this result, the gn modulo m. See in example 1, you are given a, b, and c as 3, n is 3, and m is 5. So you calculate it that, and you know one thing, that the g1, see it's given over here, g1 equals to 1 and g2 equals to 1. So so as a normal Fibonacci number, the first two numbers are given over here also. It depends on the previous two numbers. Along with that, you will add a number c. Okay, the slight difference. See, for the g1 and g2 you got 1, and for g3 you will have to multiply a into g2 plus b into G1, A into G2 plus B into G1 plus C. Then G1, G2 are 1, then 3, then 3. Then again you added 3, so you got 9. But at the end you have 5 also, so M also. You have to do modulo of Gn and M. So you got 4 at the end, and that will be your answer. Similarly, for example 2 also. But since you have to solve this question in order of log n, you will be applying a method called matrix exponentiation. It is a method usually when you have to calculate the power of a number, let's say a raised to the power n, you have to do order of n operations in order to find the a raised to the power n. But using matrix exponentiation, you will be able to find a raised to the power n in only order of log n operations. So that is what we will be applying over here. And along with that, for matrix, I will be using numpy matrix, numpy array, since we are using in Python. So it will also again reduce the complexity and time complexity of the solution. So first thing, base condition, if n is less than or equal to 2, if n is less than or equal to 2, this function will return 1, because we are given the first and second Fibonacci numbers, which is g1 is 1 and g2 is 1 also again. Okay, so we return 1. Then we'll initialize 3 cross 3 identity matrix as the initial result matrix. Initial result matrix np dot array. np dot array. This is the initial identity matrix. What it will do is it will represent the first two Fibonacci numbers and the constant number c. This initial identity matrix, okay, identity matrix, initial result matrix will represent the first two Fibonacci numbers and the constant number, third constant number c, which is given in the question as an input. See, for the row 1, it is a. For row 2, it is 2 at the mid index, second index, and for the row 3 it is at 3, which means the A, B, and C. Cool. Again, we will generate, we'll create, we'll generate a transformational matrix. We'll generate a transformational matrix which will be used to store, which will be used to store and further generate and then store the next Fibonacci number from the current state. Okay, so I will name it GenFib. You can give GenFib because generalized fib matrix. So such any such thing. So np dot array again. Now again I will reiterate, this will be a transformational matrix GenFib, which will be used to generate and store the next Fibonacci number from the current state. I will store it A, B, and C. Okay. Now I will reduce the value of n by 2 because for the two options, for the initial two, last two, we already have the solution. Okay. So I will iterate through this entire value of n. Okay. Iteratively, and by iterating, I will update this result matrix result. Okay. Now, if n is an odd number, the last number is set bit, and multiply. And again, we will use matrix multiplication, which is inbuilt function of numpy array in Python. We'll multiply the result matrix with genfib matrix and we'll write the modulo of it. Okay. So what we are doing over here is we are iteratively updating the result matrix. We are iteratively updating the result matrix, which is RIS, by multiplying it with the genfib matrix and the modulo m. And we are effectively computing the power of genfib. We will compute the power of genfib for n minus 2 times. Okay, n minus 2 times. And this is where we are using binary exponentiation or matrix exponentiation method. Why n minus 2? Because we are already doing 2 over here. This was our step where we updated the result matrix by multiplying it with the genfib matrix and doing the modulo m. At the end, I will write shift 1 in order to get closer and reduce the number of operations. At the end, I have to return the sum of the first row. Because first row will only store the nth number and sum of it will store the nth Fibonacci, generalized nth Fibonacci number. So as you can see, it does the job pretty effortlessly and in very less time because we are using matrix exponentiation method, which is a very optimized method to solve to calculate the power of a number, and we are using numpy array. So both of the two complements each other. So I hope you learned a beautiful concept today and enjoyed it. Thank you. Have a very nice day.